We continue the chapter laws of motion, and we were discussing the variation of momentum, and the first two cases already we have discussed. Now we will discuss the third case. Case number 3, when both the objects have equal linear momentum. This is the case number 3. Case number 3, two objects having equal linear momentum. Two objects having equal linear momentum. Having equal linear momentum. Two objects having equal linear momentum. Suppose their linear momentum is P1 equals to P2. First object have linear momentum P1, another object has linear momentum P2, and we are taking the case that both have the equal linear momentum, means P1 equals to P2. The formula for P1 is M1 into V1, and the formula for P2 is M2 upon V2. So V2 upon V1, it becomes equals to M1 upon M2. V2 upon V1 equals to M1 upon M2. It means if M1 is greater than M2, if M1 is greater than M2, then V1 will be less than V2, because V2 by V1 is equals to M1 by M2, means velocity is inversely proportional to the mass, means lighter body will move with larger velocity. Here M1 is heavier body, and here V1 is the velocity of heavier body. So the heavier body will have less velocity and the lighter body will have more velocity. Thus, when two objects have equal linear momentum, thus we conclude that when two objects have equal linear momentum, when two objects have equal linear momentum, then lighter object will move faster than lighter object will move faster. If two bodies have equal linear momentum, then lighter body will move faster than the heavier one. So heavier body will move with less velocity, and the lighter body will move with larger velocity, and its graph between momentum and velocity, momentum and mass. This is mass and this is velocity, mass and velocity, and its graph will be like, as the mass increases, its velocity goes on decreasing. When here the mass is less, so velocity is high. As soon as the mass goes on increasing, the velocity goes on decreasing. So this is the graph for third case, when two objects having equal linear momentum. So we have discussed all the three cases of linear momentum. Now the next topic which we are going to discuss, that is Newton's law of motion. Newton's law in motion. Newton's law. So there are three laws of motion. There are three laws of motion. The first is called Newton's first law of motion. And Newton's first law of motion also defines the inertia of rest or inertia of motion. Or we can also say that Newton's first law of motion comes from the definition of inertia of rest and inertia of motion. So if a body is in rest, if a body is in rest or it is moving, if a body is in rest, it will remain in rest. If a body is in rest, it will remain in rest. If a body is in rest, it will remain in rest, and if a body is moving, if a body is in rest, it will remain in rest, and if a body is moving, in a straight line, with uniform velocity, then it will remain in motion. Then it will remain in motion unless no any external force applied. No any external force is applied. No any external force is applied. So this is the Newton's first law of motion. And Newton's first law of motion includes law of inertia, inertia of rest as well as inertia of motion. So the definition of inertia of rest was, if a body is in rest, it will remain in rest, and the definition for inertia of motion was, if a body is in motion in a straight line with uniform velocity, then it will remain in motion in a straight line with the uniform velocity unless no any external force applied on a body. So we conclude that Newton's first law of motion comes from the law of inertia. Now we talk about the second law of motion. Newton's second law of motion, the rate of change of linear momentum. The rate of change of The rate of change of linear momentum is equal to the rate of change of linear momentum is directly proportional. The rate of change of linear momentum of a body. The rate of change of linear momentum of a body is directly proportional The rate of change of linear momentum of a body is directly proportional to the applied force. Is directly proportional to the applied force. This is the second law, Newton's second law of motion. The rate of change of linear momentum of a body is directly proportional to the applied force, and the change takes place in the direction of the applied force, and the change means change in linear momentum, and the change takes place in the direction of the applied force. So this is the Newton's second law of motion. The rate of change of linear momentum of a body is directly proportional to the applied force, and the change takes place in the direction of applied force. Then the Newton's third law of motion. Third law. To every action there is equal and opposite reaction. To every action there is equal and opposite reaction. It means equal in magnitude. The reaction will be equal in magnitude and reaction will be opposite in direction. Means action equals to minus of reaction. Action equals to minus of reaction. Action equals to minus of reaction. Here minus sign shows that the reaction acts in opposite direction. So this is about the Newton's laws, three laws. The first law states if a body is in rest, it will remain in rest, and if a body is in motion in a straight line with uniform velocity. This word is used must. If a body is moving in a straight line with a uniform velocity, then it will remain in motion. Then it will remain in motion in a straight line with uniform velocity unless no any external force applied to the body. And the second law is the rate of change of linear momentum is equal to the applied external force. The rate of change of linear momentum of a body is directly proportional to the applied force, and the change takes place in the direction of applied force. And the third law is to every action there is equal and opposite reaction. Now one by one we discuss all these three laws in detail. Discuss these three laws one by one in detail. So discussion of first law of motion. discussion of first law of motion. So the first law of motion consists three parts. The first part is, if a body is in rest, then it will remain in rest. The Newton's first law consists three parts. The first part is, if a body is in rest, it will remain in rest. The first part of Newton's law, if a body is in rest, if a body is in rest, it will remain in rest. This is the first part of Newton's first law of motion. And the second part is, if a body is in uniform motion, if a body is in uniform motion, if a body is in uniform motion in a straight line, then it will remain in uniform motion. Then it will remain in uniform motion in a straight line. Then it will remain in a straight line. Then it will remain in a straight line with uniform motion. This is the second part of Newton's first law of motion. The first part is, if a body is in rest, it will remain in rest. And the second part of the statement, if the body is in uniform motion in a straight line, then it will remain in a straight line with uniform motion, unless until no external force. And the third part is, unless until no any external force applied on it to change its direction. The third part is, unless no any external force applied on a body, to change its direction, Change its direction means change its direction of motion. So Newton's first law of motion consists three parts, or we can say that it is the combination of three different parts, in which the first part is, if a body is in rest, it will remain in rest. The second part, if a body is in uniform motion in a straight line, then it will remain in uniform motion in a straight line. And the third part is, unless no any external force applied on a body to change its direction. So one by one we discuss all these three parts. In the first part says that a body in rest will continue in rest. The first part, we will see the example of all these parts. The first part tells that if a body is in rest, it will remain in rest. So let us see an example. Suppose a chair lying on the floor. Example of first part. A chair lying on the floor. Remains on the floor. A chair lying on the floor will continue to remain there. will continue to remain there. A chair lying on the floor will continue to remain there unless we displace it. Unless we displace it. Unless we displace it. If a chair is lying on the floor, it means the chair is in rest, so it will remain in rest continuously up to long term unless we displace it. And the second part says that a body is in motion will remain in motion. If a body is, the second part is, if a body is in uniform motion in a straight line, then it will remain in a straight line in uniform motion. So example of this part is, suppose a rolling ball comes to rest on a rough ground. A rolling ball, example for second part. A rolling ball comes to rest due to the force of friction. A rolling ball comes to rest due to the force of friction. If the force of friction doesn't act, or if the friction were zero, the ball will continue in motion. If the friction were zero, the ball remains continue in motion forever. So the second part of the first law was, if a body is in motion in a straight line with uniform velocity, then it will remain in motion in a straight line with uniform velocity unless no any external force applied. So a rolling ball comes to rest due to the force of friction. If suppose the force of friction doesn't act on a body, then it will continuously remain in motion forever. So force of friction is the applied external force. And if we remove the force of friction, or if we applied external force in a direction opposite to the force of friction, then it will remain continued. So this is the example of second part of the first law of motion. And the third part, this part also indicates that to increase or decrease the speed of a body moving in a straight line, a force has to be applied on it unless no any external force applied on a body. So if we want that body remains continue in motion, so external force will be applied in opposite direction. External force applied in a direction opposite to the force of friction. If we applied an external force in a direction opposite to the force of friction, the ball remains continuous in the motion. So this is the detail about the first law of motion. Now we talk about how does Newton's first law of motion lead to the definition of force? How does Newton's first law of motion lead to the definition of force? Newton's first law of motion lead to the definition of force. Lead to the definition of force. Newton's first law of motion lead to the definition of force. How it lead to the definition of force? We see that according to Newton's first law of motion, the body at rest or in uniform motion will remain at rest or uniform motion, which we have already studied unless no any external force applied on it. So no any external force applied on it. The first law is a body is in motion, it will remain in motion. If it is in rest, it will remain in rest unless no any external force applied. It means there is an external agency. This shows that force is an agency. This statement, the first law, the statement of the Newton's first law, which is if a body is in rest, it will remain in rest, and if a body is in uniform motion in a straight line, will remain in a straight line motion in uniform if no any external force is applied. So this indicates that force is an agency. This indicates that force is an agency. Force is an agency which either changes the state of rest, which either changes the state of rest or a state of uniform motion, or a state of uniform motion. So from Newton's first law of motion, we conclude that force is an agency which either changes the state of rest or uniform motion. But sometimes a force applied on a body, but sometimes a force applied on a body is not able to change the state of rest or a state of uniform motion. But sometimes a force applied on a body doesn't able to change the state of rest or a state of uniform motion or a state of uniform motion. Suppose the force, external force acting is very less, very negligible. So it doesn't change the state of rest or a state of uniform motion. So the exact definition of force is that force is an agency which either changes or tends to change or tend to change the state of rest or a state of uniform motion. This is the complete definition. Force is an agency which either changes or tends to change the state of rest or of a state of uniform motion. Thus, the exact definition is that force is an external agency which either changes the state of rest or a state of uniform motion, which either changes or tends to change the state of rest or of uniform motion. In the next video, we will discuss about illustrations of the Newton's first law of motion.